anyone know they're going to be gone the last week of prep?
No clue.
Besides those that have told me. Anyone else?
No. I might. I might be gone.
I'm gonna be sort of gone the last week.
I think I might be. I might. It's possible.
Okay, again, next team, guys,
22nd.
if you know you're going to be gone, raise your hand. What day are you going to be gone?
The 19th through the 22nd ish.
All week?
Ish.
Yeah,
Wait.
I mean,
Here, let me see. I think it might actually be the 20th through the 20th.
so either you're gone or not gone. Let me know. Okay, I got you.
Yeah, I'll be gone the 19th through the 22nd.
Okay. You need to take your finals next week. You're going to take 3 tests next week. Plus all the other stuff we're doing. Same with you, Abby. Okay? Okay, we're going to get through exercise 19 today. Okay, we left on example 36. Okay, the gloves, I need those put away because they're a distraction. Okay, there's several of you that have them. Please put them away.
And finger gloves.
Put them away, please. Okay, Emily, please put yours away. Please put them away.
Well, can I drop my own?
You guys, you can keep them, like put them in your backpacks,
Put in your backpack, that's all you gotta do.
but just not during class, okay? If you see it during class, we'll take them away.
I don't want you guys to be too distracted. Okay, we're going to get through this example and then get through exercise 19. And then we will talk about our test, what's on it. Okay, so you guys need to take some notes about what's on the test. You guys should do very well on the test. I got finished rewriting it this morning. You guys should do very well. I don't think, after looking at your guys' quiz this last week, that we took last week, looking at the test, you guys should do really well if you get to review your quizzes and whatnot. So, all right. Wrong light. Down. You guys see okay?
Yep.
All right. So we started with this yesterday, and then we had to go. We are trying to prove that the argument is valid. Now, this is an argument with quantified statements. We're used to arguments with just our normal statements. To prove that an argument is valid, you have to show that its conditional statement is a what?
Tautology.
Tautology, okay? Now, there's 2 ways to prove arguments that are valid. Okay, we have one way where we're saying, hey, in this argument, we talked, let's see, we didn't do that part yesterday. So we can prove through a truth table, which is not what we're doing right now. We're going to use a 2-column proof. On your guys' your test, you will be given, this will be just like the quiz. What I'll give you is I'll give you P1, P2, and conclusion. You have to fill in the statement that goes here, the statement that goes here, the statement that goes here. That's what you're going to have to do. You're going to have to fill in the blanks here, here, and here. This is going to be a different question, obviously. In this case, all camellias are white. Blue bonnet is not white, therefore blue bonnet is not a camellia. C is the predicate is a camellia. W is the predicate is white. Okay, we have our symbolic form, and then here's our proof. When you guys are given the proof, okay, I'm going to show you guys I told the formula sheet. I told you guys you don't have to memorize formulas, right? And our theorems, you don't have to memorize those. So I'll show you that today and what's on it. You may or may not have to use things that are on it. So when we have our proof, we look at our premises. Okay, those are gonna have to be in there. I will put the left side of the two-column proof in on any two-column proof you have. I'm gonna put in the left side. You guys have two two-column proofs. One is for points, one's for extra credit. You have up to 15 points of extra credit on this test. Okay, so it's a good idea to try the question and do your best. So it's a lot of points that you can get. That
What if we get 150?
then you're gonna get 115. It's gonna up your grade. It's great. So, then you have to give the reasons, and the reasons, okay. The reason we talked about yesterday. So we have these two premises. We know for every x, x is a cat, or sorry, x is a camellia if x is white, and then in this case we're saying the blue bonnet is not white, right? Yes.
Yep.
You with me? So that's our premises. Then we say, well, if we take this conditional statement out and put it here, if the blue bonnet is camellia, then the blue bonnet is what? White. Instantiation or term substitution. So what we did is we replaced the x's with blue bonnet. Blue bonnet is our term substitution, our instantiation. That's what we're replacing. Okay, so all this is talking about on this proof and the one before is we looked at replacing that x value with blue bonnet because we've established that x in this case is blue bonnet. Yes?
On your reasons, could you write just either or instantiation or term substitution, or do you have to write both of them?
If you give me one of these, I will be happy. Yeah, you can write instantiation or you can write term substitution. I will still mark you right. I just want you guys to be able to recognize what's happening. Oh yeah, we substituted the x's out here in here.
Yes.
Okay, good. Well, what that means now is if I have a conditional statement, that conditional statement with a conjunction with not a blue bonnet is not white, then we can say that's the conjunction of 3 and 2. We made a conjunction here with premise 2. And that's what you have to be able to see is that it's a conjunction with two statements that we have. It's nothing new. This is really what we did last week on our quiz. Then you make your conclusion. Okay, we said our conclusion is the blue bonnet is not a camellia. That's our conclusion. And that's from this step to this step. This rule right here implies this. Okay, we've just proven the argument. So that's by rule of modus tollens. And you'll be given the rule of modus tollens to know that, oh, if I take a conditional statement as a conjunction with not a statement, then that's the rule of modus tollens. And you guys will see that on your formula sheet. Then you have to give me a conclusion. Okay, I left a spot. I said conclusion. You guys have to write a conclusion for me on every proof you have. Okay? So let's go ahead and practice this real quick. On exercise 19, you have the symbolic form. What we're going to do is write the symbolic form for the following argument. All insects have 6 legs. An ant is an insect, therefore an ant has 6 legs. So let I be the predicate is an insect. Let S be the predicate is the creature has 6 legs. A creature has 6 legs. Okay, go ahead and write the symbolic form right here in the blank. Here in this blank here. Write the symbolic form. So pencil should be going. Write a symbolic form. Ready, go. Symbolic form. So you need P1, P2, conclusion, symbolically. P1, P2, conclusion. Yes, Zach?
I thought we were supposed to do this for homework.
Good. Then you're done, right?
Yeah.
Good. So if you haven't done it, go ahead and please do it. Okay, write the argument in symbolic form. Lucia did it. Great job. Remember, I is an insect. Premise one, who's got that for me? What do you got, Abby?
If for every x, if x is an insect, then x has 6 legs.
So what would I write letter-wise right here?
I,
I,
x, arrow, s, x.
okay, do we agree with her?
Yeah.
That's our first statement, okay? So if we look at this, all insects have 6 legs. That's what this says, all insects have 6 legs. But we write it, okay, remember there's different ways to interpret the same meaning. So this is for every x, which is the all part, all, for every, right? Insects have 6 legs. So insects, if it is an insect, then it has 6 legs. All insects have 6 legs. Very good. Okay, premise 2, okay, what do you got?
I
You got what?
and
So, sorry, what, do you want me to write I?
yeah, just I and because it has
And is an insect, okay. What am I writing?
I and.
And,
Yeah, but like it's gonna be the term.
it's gonna be the term.
Yeah.
The X,
And is the
like
term.
IX.
Oh. So you're saying I and subscript ant, like this.
Yeah.
Okay, do we agree with this?
Yes.
Okay, if we have an ant is an insect, is that what this statement says? Now, is an insect, an ant is an insect. So we put a term with this to be ant. Okay? Yes, Tatum.
The conclusion is S
S what?
and.
S and.
Add another A on there, it's Santa.
Say what?
Add another A on there, it's Santa.
It is. Okay. Any questions on our symbolic form here? Yeah.
I'm just gonna use that why we did I do like an ant is an insect, so I did AX then IX, like if ant then insect.
Okay. That's a good question. It comes from right here. Let I be the predicate is an insect.
Oh, okay.
And we're saying that an ant is an insect, so this is our term, ant. And then is an insect is the predicate. The predicate is going to be our capital letter. Okay? Other questions? So again, that would be part of your test. This is actually what the bonus question's like on your test, guys.
That's a bonus question?
This is going to be part of the bonus question. That's 5 points. So for some of you, it can help you out quite a bit. Now we're going to go to the next part. Construct a proof for the argument above. So we need statements and reasons. Okay, statements and reasons. I want you guys to try to come up with what you can right now for this. So go ahead and make a two-column proof on your paper. Do one side statement, one side reason, and fill in what you think you can. Okay, I'm going to tell you right now, I'll tell you how many statements there are, which will tell you how many reasons there are. You need 5 statements and 5 reasons. Okay, go ahead and draw that up. So right, here we go. You're ready. You're going.
Wait, 5 reasons and 5 statements?
5 statements, 5 reasons. Statements are on the left. Reasons are on the right. So you should construct a two-column proof that looks similar to this. You have your statements and your reasons. And again, yeah, I'll give you the left side on the test. That's done. But we're going to try doing it without me giving it to you here. Okay?
So on the test, we don't have to come up with this statement?
On the test, you don't put the statements. It's done. I think that's more fair to you, so just for kind of the level we're looking at right now. So my first statement. Who wants to give a shot at the first statement? Answers just all of a sudden started flying up. Okay, we'll go, Damien. Oh!
So
Okay, that'll be our reason. But you said premise one, what is premise one?
For every x is in sex. Wait, I don't know how to say it.
Okay, what am I gonna write in here? I'm gonna write some letters, right?
I, then x, and then arrow x.
That was our first premise, right? That was our first premise. Okay, thank you. Second one.
Premise two is
I and. Okay, and that's gonna be a premise. That's our reason for writing it. So our premises, okay, those give us a starting point in a proof. There are givens. If you write given here, that's good, right? We talked about that. So that's what we start with. We have to start with the premise to get the conclusion. So now we're going to turn the premise, we're going to manipulate them, make them look a little different to turn them into the conclusion. So right now, we know statement 5, because I told you there's only 5 in this case, right? Statement 5 is going to be what?
Conclusion.
It's going to be the conclusion. And what's our conclusion?
Essay.
What's our conclusion?
Me?
Yep.
Essay.
S and what am I going to write here? Do we know yet? Does anyone have an idea? Now we might not write this quite yet. There's going to be something that's going to lead up to it. Let's go back just a little bit. I know some of you might have it. That's good. So let's get 3 and 4 done, and we'll come back to this last part. This is probably the most important part on how we get to that conclusion. We do know that this is SN. That's what we want to get to. So in a proof, start out with what you have. Identify where you're going. Right? Start out with what you have. Identify where you're going. Okay. Who hasn't answered anything today? Okay, you've already answered something. Put your hand down. Okay, what do you got, James? What's next on our statements?
It's I am the essay.
I am.
By,
Then, you mean conditional statement?
yeah,
Okay.
and it's either called instantiation or term substitution.
So, can you explain why we call it instantiation or term substitution? Instantiation.
Because X is the term, and we also have int as a term, and X is a variable, but int is a number, so we replace X with, we replace X with int,
So is this true? Does x equal int?
in this case, it does, but in other cases it might not.
So in other arguments, x is something else, right?
Yeah.
So in this particular argument with quantified statements, our x is an int. Term substitution.
It's
like a
substitute for the term.
Huh?
It's like a substitute for the term.
Yes, we're substituting the x term to be ant. Yes. Okay, Shred, what's the next one?
Well, I'm just confused at why we do and instead of just x. Because if x equals and, why not just keep an x?
Because we don't know that x is ant down here. So we're trying to show that using these premises, we can get this. Because here, x is not it's just x, yes? But if we say, well, if this is our premise, these two premises, we can substitute ant in for x, and we have to get this. We can't say that this is sx because we haven't established, I mean, maybe this is wrong to me to say x is equal to ant, but essentially that's what we're saying by term substitution. Because if we were just to start with these two premises, we can't just say, oh, s ant is going to be our conclusion without showing why. So the way it works is we got to use these two premises together to show, oh yeah, we're going to substitute ant in here by term substitution here and here. That's part of the premise. So the premise establishes that you can move ant in for x.
So is there any cases where we don't know the conclusion and don't know what to make x?
When you write a proof, you may not be able to get to the conclusion if it's unprovable, right? In this case, we're proving something that we are told is true, but we have to come up with the idea on how to show it's true.
So so if we didn't have a conclusion, we could just make X anything we wanted, or?
Not necessarily. The idea that and is coming from here, okay, that X, the fact that we substitute and in for X doesn't come from the conclusion. It comes from this premise. Because we know this. So the premise is what we know. The conclusion is what we hope to achieve. Okay? We don't know that this is true yet, necessarily. We want to show that it's true. So we know that for every X is an insect, then X has 6 legs, right? We're saying, well, an ant is an insect. These are the two things we know. Do these two things tell us that this is indeed our conclusion? So, the fact that X is an ant is why we can substitute here and here. Does that answer your question? Okay, now I'm going to have you finish this part right here. What goes into step 4, you know?
Upside down A and?
Upside down A N. Okay, not quite. Okay, thanks for your other question though. What do you got?
I ant and S ant in a disjunction with S
I ant. Okay. And?
Yeah.
So conjunction?
Yeah, conjunction.
S ant.
In a disjunction with S ant.
Okay.
Mr. Robinson?
Why do you think that's it?
Because I ant and S ant gives you S ant, and
So you're referring to 3 here?
yeah.
Okay. So you said conjunction here, yes? Where did the conjunction come from? What's your reasoning for getting to a conjunction here?
If they were both combined, they would give you S ant.
Okay. Now, why? Yeah, I like the reasoning though. Good job. Who thinks they might be able to switch this up just a little bit? She's close. She's super close. Okay. What do you got?
Okay, if I ant, conditional statement with S ant,
Good.
but it has to be a conjunction with I ant, because the rule we're using here is a conjunction with premise 2. And X ant isn't a premise, that is our conclusion.
Okay, we're going to say a conjunction is what you think.
And then I ant.
And. Okay? So you're saying this is a conjunction with what?
When it's a conjunction of premise 1 and premise 2.
No, 2 and 3.
Oh, 2 and 1 and 2.
So we would say premise.
1 and 2, because it's just premise 1 without the AX.
Of statement, let's do a statement 3 and premise 2, right? Okay, so statement 3 and premise 2. Or you can say step 3 and step 2. Or statement 3, step 2. Statement 3 and there's different ways you can say it. This is sufficient. We could just put a 2 here, that's fine. Okay, the one's fine. Now, this is probably these 2 steps are probably the hardest. The reason this is a conditional statement, okay, right here, is because that's what we know. We can't come up with information that we can't back up or information that we don't know. We do know that if ant, okay, if an ant is an insect, then an ant has 6 legs, right? That's what we know from statement 3. Then we're going to say, well, we want to make a conjunction with statement 2. What this is going to help us show is statement 5. Now, what rule tells us that we can go from statement 4 to statement 5, Maggie? What's the reason?
The rule of
Oh, bouncy.
that was
What reasoning do we have? Modus what?
Modus tollens.
Close.
Modus ponens.
Modus ponens
Aha! That's right.
on for. Okay? Well, modus ponens says, look, if you have one statement, in this case iant, if iant, then esant, then as a conjunction with iant, modus ponens says, hey, look, that's logically equivalent to what? Esant in this case. That's what modus ponens says. But modus ponens, now when we look at the rule, okay, if you were to go look at modus ponens on, like example 12, okay, it would use different values. Okay, in this case, we're saying if we have a conditional statement of two values, as a conjunction with the first statement in our conditional statement, okay, then that is going to be our last statement in the conditional statement. Questions? Yes?
Do we have to write a statement afterwards saying that this is, that the, argument is valid?
Huh?
For this, we have to, for this, table, we have to write after we are finished, the statement that says that our argument is valid?
It is valid. So you say, therefore, the argument is valid. And I leave a spot for you to write that. So it's very obvious for you on the test. Good question. Okay, other questions? Yeah, that's most of exercise 19. We're going to look at the rest of it. What do you got, Trev?
So, how do you know on 4 that it's gonna be a conjunction?
How do I know on 4 it's going to be a conjunction? Okay. What we have to do, step 4, we have to say, how can we use steps 1, 2, and 3 to get to step 5? So you have to see that, oh, I know if I make a conjunction with the conditional statement and with this statement here, that I'm going to get step 5. So you have to notice in advance that you're going to use modus ponens to get here. But you have, how do you use modus ponens to get there? Well, you have to have this conjunction in place.
Okay.
Does that make sense?
Yeah.
So it's like, again, if we go back to our normal math that we're used to, okay, if I gave you guys some steps, the way you would recognize this, I'm going to show you, so if I have 2 times x plus 2, and I know that I have to get 2x plus 4, right? So, what does this, maybe I should start like this. What has to happen between here and here to get, what would the step be here?
Distributive property.
I would have to distribute and say, okay, that's going to be 2x plus 4 distributive property, and then that gives me my answer. Does that make sense?
Yeah.
So it's the same kind of logic. So a lot of you guys have been asking, okay, when am I going to use logic? When am I going to use logic? When you go back to school, you're going to be presented with stuff you're more familiar with. These are logical statements. You're using rules to get what you want. Now, any kind of argument you make in life, okay, whether you're in business or education or science fields, whatever you're in, you have to be able to make logical statements. You have to be able to back them up. Here, you've got information to present. Well, how can you get the conclusion you want if you're, let's say, in an argument? Is this not an argument?
It is.
It is, right? Okay? We're teaching you how to logically reason, okay, reasoning, okay, which helps you in other subjects. It may not be a direct payoff, but you guys are thinking at a much deeper level than your average, what, you guys going into 7th grade, right?
Yeah.
Okay, you're thinking at a much deeper level than the normal 7th grader. So, yes, there is payoff behind all this logic stuff you've been doing this summer, but like I said, it's not a direct thing you're going to see right off the bat. It's something you're going to have to learn to recognize. Oh yeah, that is a reasoning skill. Okay. Questions? Okay, let's look at the last part here. Number 2. Okay. I want you guys to go ahead and try this one. Go ahead and give it a try. you're going to do the same thing. Make a symbolic argument, make a proof. Ready, go. Quick. Writing, go, writing. I know there's probably a few of you that are done, but I know there's a lot of you that aren't. Okay? You guys got what, number 2? Alright, good. James, you got number 2 now? Okay. Good. Something started, good. Started. Something you guys want to be aware of, if I write it on the board, it should go on your paper. Anytime you're in any kind of class, at SU, prep, or in high school, or college, if the teacher puts it on the board, put it on paper. Even though you might not look at it again, it's good to have. Erase this. Okay, all whales are mammals. An oyster is not a mammal, therefore an oyster is not a whale. Sounds pretty straightforward, right? It's like, well done. We got to prove that the argument above is valid, so we construct a proof of the argument. All whales are mammals, so I need symbolic form first. I need the symbolic form. Okay? Put your hands down if you've already got one today. Okay, I want to try to get everyone to try something. Maya, what do you got?
Okay, so,
Oh, that was a bad one.
okay, so P1 is, for every AX, WX, if WX, then MX.
Okay, so if X is well, then X is a mammal.
Yep.
Okay, and they tell us M is a mammal, W is predicate as well. You good on that?
Yep.
Okay, so that's going to be our first premise. Okay, Katerina, what do you got?
I got for my second premise, not an oyster.
Did you say
Not-
that is oyster, not mammal?
And oyster.
Yeah.
So an oyster is not a mammal.
Yeah.
Okay, is that what that says?
Yeah.
Okay. Our conclusion.
Kind of looks like monster.
Moisture. Moisture. It's like how you hear people say the word moisture. It's moisture.
And then
Okay,
W.
next, what do you got?
W is oyster.
Not W oyster. Okay? Is that what the conclusion says? The conclusion says therefore an oyster is not a well, an oyster is not a well. We all agree? Okay. Next part, we have statements and reasons. Statements and reasons. This time, well, what do you guys think? Can you do it in less than 5? That would be the question. Kaden, what do you think? Can you do this in less than 5?
No.
No. Less than 5 what?
Statements.
No. Yes.
Yes?
Do you know for sure? That'd be the question. James, what do you think? We're gonna do it. So we'll check this out. Is that okay?
Unless we cut out some of the detail which isn't good, I don't think we really can.
Okay. What are we trying to prove is now the question. So let's put in some pieces. What are we trying to do? I need someone that hasn't answered. Someone that hasn't answered. Okay.
Sort of not answered.
Okay.
But that's the story.
Maggie, you got one, right?
What?
You already got one, right?
I got
Yeah. Everybody got it.
I just heard these are every X, that X is a well, then X is
be our premise. Okay. Now we need a second statement. Second statement. What do you got?
Not an oyster.
Not an oyster.
Yes, premise.
An oyster is not a mammal.
Okay. An oyster is not a mammal. Okay. All right. And you said that this was a premise?
Yes.
I didn't write it. Okay, statement 3. Hey, Tim, I'm gonna wait till we got more people, okay? We've got one today. Others? Someone that hasn't answered one.
So could it be somebody who has answered one?
No, I wanna try to get more people. Gary, you got an idea? Wanna try it? So we've gotta get to what? So you can give me 3, 4, or 5. What are we trying to prove? That an oyster is not a whale, right? That's our conclusion. Okay, very good. Okay. All right. That's our conclusion. But now what's statement 3? I need statement 3. Who hasn't gone and give me statement 3? You ever got to be scanned yet? You got one. Okay? Choose one. I didn't get one.
Can I retry? I got Twizzlers.
Okay, who didn't even get to be scanned yet? There's the question. I got you one, didn't I?
No.
Brooke hasn't done it.
Go for it, Brooke. What do we got for statement 3? Give it a try. You know what the worst thing can happen is it could be wrong. That's the worst thing. It doesn't matter if it's right or wrong? No.
Not an oyster.
Not a what?
Not an oyster.
What letter we use? Oh, M? Not M, oyster? Okay, that would be the same as our premise here, right? So we might not necessarily need the same thing. So what can we conclude using these two statements? What else can we write using these two statements? Can I assume anything else, given that I have this and this? And what have we been focusing on? Term what? Term substitution. So what term can I substitute with these guys?
On what?
So if I use this one and this one, what can I assume using term substitution? And it is? Okay. What are terms? The X's, the oysters, the W, the M, what are the terms? The X's and oyster, yes? So X is an oyster. So that's what I'm going to substitute. So I'm going to say W, oyster. If oyster is a whale, then an oyster is an animal. Right? Does that work? So that would be term substitution, right? Or instantiation. Substitution. I can't even spell. Term substitution. Okay. There you go. Yes. And she might be for a little while. That's forgive. That's what friends do.
Forgive me.
She did a great job though. Okay? Now I have to be able to take this conditional statement and use it to get to this idea. Okay? Who else hasn't gone? Gabrielle, who else hasn't gone? Who else are we going to throw in the bus? Harley, what are we going to do? What do you think you can try? We'll just leave it to Katarina to throw everyone on the bus. Okay? So let's look previously. Okay, let's look. We have a pattern going here, right? Between this proof, guys. Hey, stay with me. So we have a pattern happen between this proof and last proof. Can the pattern stay the same? Are we trying to prove essentially the same thing?
Yes.
The argument is really the same with different variables and different terms and predicates, right?
Yes.
Except the last one.
Except the last one. Because we have a not here, right?
Yeah,
There's a not.
I know that.
Whereas before we didn't have a not. So, Harley, assuming that this is staying the same, this is I chew up the grass, okay? Try to give me your best option here of what you can put for statement form. What you think might be able to put based on our other arguments. Yep.
And then
Arrow. Super close. We know that this statement's what we have, right? So we gotta use statements that we have to make a new statement. So M, oyster. And we're gonna put that, we're gonna say, okay, we're gonna use statement 3, and we're gonna make it as a conjunction with not M, oyster.
can I
Thank you for trying. Appreciate it. Okay?
Okay.
Yeah, one second, we're coming back. Okay? So, Katarina, who is our next person? Huh? Rayleigh. You, it's a high two. Here, I'll give it to you in advance. You pay in advance. Okay. So, Rayleigh, what could possibly be our reason? Now, what did we make? So think about what we made. We made a what? What's this second? What is this? Huh? An and, which is a conjunction. So we made a conjunction of which two statements? Not number 5. Think about which two statements we put together. We put this, see this statement right here, right? That's statement 3, it went right here. We made a conjunction of statement 3 and which other statement? Huh? What other, so look at our other statements. We put 3 and which other one together? 2. So if we can picture, okay, we've got to use the statements we have to get the statement that we want here. This statement is going to help us get to this one. So we made a conjunction of statement 3 and statement 2.
Can I do the next one? The reasoning?
Well, the Katarina is on a roll here. So
Throw me under.
we have one blank left.
Throw me under.
Max!
No, I've gone. He has.
Oh, Max!
Okay, Max.
Oh,
What kind of throw is that?
dude, you know, did I ever tell you why I quit baseball?
Oh.
Did I tell you that? Okay, you guys want to hear my baseball story real quick? Okay.
Couldn't throw, you got picked on.
No, I can throw really hard. Like so hard, it made the other kids scared. So I'd throw the ball, and I'd beat the kid, and the next kid get up to bat, and he'd like, you know, okay? So, the reason, one of the reasons. So I can throw hard, but I can throw straight. That's the big reason. But one thing that kind of cracked the egg for me is us pitching. Okay? So just, you know, beat you, okay? I didn't. But I pitched it, and I let go of it like right here. And so, look at the angle. It was really high, right? It went over the backstop. Yeah, did you guys ever see that happen? This is a magic trick. I'm like, hey, where'd the ball go? And I'm lucky the kid didn't swing because he was so scared. Might have been nervous. But yeah, that was kind of one that cracked the camel's back there. So, Max. What do you got for the reason here, Max? So,
It's 12:11.
hey, stay with me. Stay with me. We got to answer this question, and we got to talk about our test. Okay? We're going to use one of the modus somethings. Okay? So, here's what I'm going to show you. Okay? Give me a hand for a second. Okay? Max says, look, modus something. Modus something. It could be modus tollens. It could be modus colons. happens. Okay? But look at what we have, okay? We need to look at the statement here. Guys, I need you to put your hands down. Listen. Okay, just listen for a second. Okay, we have a conditional statement. As a conjunction with a not statement. Yes? You guys see it? Okay. In your test, okay, I'm going to pull up the test right now and show you some things. I mean, this is from the actual test. No, there's no answers on the test right now. It's, the answer key. So, woo, there's a test. Woo! Oh, dang it, I haven't. Look at me. Okay, listen. Guys, I need you to listen. If we want to leave on time for lunch, I need you to stay with me here. Okay? If we look, this is going to be your sheet. Okay, I know it's super hard to see with the writing on there, but if we come down here, we have modus ponens and modus tollens. Okay, modus tollens is a conjunction with a conditional statement and a not statement, which implies not P. Okay, so look at where the P is. That's our, what's this term called, the conditional statement? Antecedent. So if we have our antecedent and then our consequent as a conjunction with the not consequent, that gives us the not antecedent. This is the one we want, is modus tollens, because it's very similar to this guy down here. We have a conjunction with a not, okay, consequent, not consequent, and then we want to get not oyster. That's the not antecedent. So, rule of modus what next? Modus tollens. Good. See? Okay, let's go back here. Okay, rule of modus tollens. On statement 4. Okay? So, that's our proof. Okay, I'm going to tell you, don't take your notes don't put your notes away. Listen, I'm going to tell you what's on the test. Okay? Listen very carefully. I get a pencil, write this down. Get a pencil, write it down. Okay, where you all bombed the last test, if you bombed, okay? If you bombed the vocabulary, and then the rest of it was a little more difficult for you. That's not going to necessarily be the case here. I think the vocabulary is essential, but it's not as vital. Okay? So go ahead and here's what you have to know. Listen carefully. Okay? The first 6 questions, you're going to have to know how to use the following words. You have to know what a tautology is. You have to know what a conclusion is, what a contradiction is, what a universal quantifier is, what an existential quantifier is, what an implication or implies means. Okay, that's the big arrow, right? Fat arrow. An argument, and you have to be able to use the word premises. So those are the words you have to use again. Here are the words again. Okay? Tautology. Conclusion. Contradiction. Universal quantifier. Implication or implies. We going slow down?
Yeah.
Existential quantifier. Argument. Premises. Katarina.
Okay, are you trying to ruin my childhood? This sounds like a lot of vocabulary.
But you guys all know it. You guys know what tautology is. It's when your truth table is all what? Argument and premises. Okay, so those are the words you need to be aware of. Basically, remember, this is between exercises 11 and 19. If you can do exercises 11 and 19, you're good. You will do well on this test. Okay? I can almost guarantee you'll do well if you just know how to do those exercises. Next thing on the test, here's the second page. That's the second page. Okay? You will have every theorem and every argument you need. Okay? Here. Are you going to use all of them? No. Probably not. Probably won't use them all. You have more here than what you'll need. Could you use most of them? Possibly. Okay? So that's the second page. This is what you're going to be given. Okay? You're going to be given all this stuff. Okay? The second page can help you with some of the definitions if in some cases. Okay, third page of the test. Listen carefully. Okay? The third page, you will prove that a specific conditional statement is a tautology by filling in a truth table. Okay? You will prove that a specific statement, conditional statement, is a tautology by filling in the truth table. So if you're good at filling in truth tables, question 7 is almost a given for you. Okay? I filled in the first couple statements of the truth table for every truth table you're filling in. One thing on the truth tables you need to be careful of, as some of you aren't, is you need to make your T's very clear and your F's very clear. Yes?
Is it a 3-column table like PQ and R, or is it just PQ?
On question 7, it's 2-column, PQ. On question 8, it's a PQR. Okay, so again, on question 8, you're proving that the argument or the implication is valid. Okay, on question 8, you're proving that the argument is valid by using a truth table. Trev?
Are we gonna need to fill up the very top line of the truth table? Like
Nope.
where this
I filled in the top line and the first 2 or 3 columns. Okay? So I'll show you question 8. I mean, it's not going to help you too much. There's no phones out, right? No phones out. Okay? Look, this is question 8. Okay? I gave you the columns. Put the phones away, please. Okay? I gave you the columns. I gave you the first 3 columns. I gave you the top row.
That's easy.
There's question 7, too.
That's fairly easy.
Like I said, you guys should blow this test out of the water. I think you're well prepared. That's just me. Okay, no, we've got to move forward. Hey, you guys want to go to lunch on time, right?
Yes.
Okay, I'm trying to give you hints on the test here. Question 9. You're going to prove that the rule of modus tollens, which is an argument, because modus tollens, the rule of modus tollens is an argument. You're going to prove that that